everybody, I want to go over a few quick things from section 6.2, and I want to start with the calculator. So when you put things into the calculator, when you're trying to do the trig functions in the calculator, it's important that you pay attention to whether you are in degrees or if you are in radians. So I will show that a couple of ways. One thing I thought I should show is Desmos, just to say like how would I do it in there. All right, so I'm going to start with sine of 30, and the reason I start with sine of 30 is because we talked about the fact that the sine of 30 is a half. It might be nice to put whatever degree you have in parentheses, that way you can really see what's happening. Now you can see it doesn't say 1/2, even though I told you that's what it's supposed to be, and the reason is it's not measuring in degrees right now. So if I go over to the settings, I need to look for, is it in radians, which it is highlighted, or do I want it to be in degrees? So I'm going to hit degrees. And immediately when I hit degrees, now it says a half, so I have the right thing. So let's do the sine of 57. I can see what it is. Now notice you're going to have to round. The homework should tell you how many decimal places to round to. Here's cosecant of 113. So I can see I switched to degrees, and now I get the right answers. Now the next one I have was tangent, and it was pi. I'm just going to type pi to get pi over 8. I'm in degrees right now, so I'm getting this really small answer. This is not correct. So for this one, again, go back to the settings. Let's go back to radians, and now it's going to say 0.414. Now, something that happens in Desmos is it's going to change all of them. So make sure you're writing down the answers in degrees as you get them. When you get to radians, write that one down, but it does switch them all. So pay attention to that. If instead, let's say you're using the TI, so same kind of thing, I like to do a test. So even if you're doing the homework, maybe it's good to test it. Sine of 30 and it says 0.5, that says, okay, great. This is in degrees is what I want, but I had that one later that says tangent of pi over 8. So let's go ahead and hit tangent, and then I need to hit pi, which is up here over the up arrow, and then divide by 8. Now this answer is in degrees. So what I want to do is go to the mode, and I want to change to radians. And then I can go back and say, hey, let's do that again. I'm going to hit second enter, it brings it back, and see how I get a completely different answer. So really be aware of every time you grab your calculator, what your mode is in. Make sure you're in radians when you're supposed to put in pi. Make sure you're in degrees when you want to put in an angle in degrees, because it will change your answer an awful lot. Another thing I wanted to talk about is, well, what happens if I don't have a unit circle? What if I have a radius that's different from 1? And it could be bigger, it could be smaller, it really doesn't matter, but we have to say, well, what are we going to do? So there will be some consistency. Sine will still be y, but now I have to divide by r. Cosine will still be x, I will still divide by r. Tangent will still be sine over cosine, so this is y over x. Cosecant, I will still flip it. This will be r over y. Secant, I'm going to flip cosine. There's r over x. And then cotangent, I'm going to flip tangent, so it's x over y. So I still have this feeling over and over that sine and cosine, those are the ones I need to know, right? If I know sine and cosine, I can figure out the rest, right? Like I can figure out what's going to happen. Let me just briefly say, because I probably went a little fast there, the tangent was sine y over r divided by cosine, which is x over r. And we said when I divide by a fraction, I multiply by the reciprocal. So I flipped x over r to r over x. The r's cancel. I get y over x still. Notice tangent and cotangent don't have the r in the answer at all. Sine, cosine, cosecant, secant do. Tangent and cotangent do not, just something to be aware of. So I said, let's find the values of the trig function at the point 5 over 12. So what I'm picturing here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I have a point up here. You all know how I draw, not that well. There's some kind of circle around it, right? But what's important is I have this point 5, 12. Okay, what I don't know is I don't know this radius, right? So this terrible circle that I drew has a radius, and that radius is not equal to 1. So what you look at is, again, if I could draw well, is I have a triangle. This is up 12, this is over 5. I don't know this r, so we're going to say 5 squared plus 12 squared is r squared. So Pythagorean theorem comes up over and over again. So 5 squared is 25, 12 squared is 144. You add that together, you get 169. That's r squared. You take the square root, r is 13. So now I know this is 13. So that's important when I go to do the sine of this theta. Sine of theta, it's going to be the y, which was 12, over r, which was 13. Cosine is going to be the x, which is 5, over the r, which was 13. Tangent, I just go 12 over 5. I'm not going to change that to a decimal or anything. I'm just going to leave it alone. That is absolutely fine. Cosecant, I'm going to flip over, 13 over 12. Secant, I flip over cosine, that's 13 over 5. Tangent, I flip over, that's 5 over 12. So if there's an r that is different from 1, it's not a big deal. It's just go back and use the Pythagorean theorem to figure out what the r is going to be. We'll continue to build on this idea as we go on to other sections, but I think it's really important to just start getting used to the unit circle, start practicing with it, maybe get a blank one and fill in some numbers, because the more you do, of course, the better you're going to get.